Okay guys, so here we have a very intricate puzzle that I made. Alright, let me just read it out to you. A baker's hedge I say. Now, firstly, you'll see that I rhyme H with H. Now, firstly, I just want to give you some time to read it. So, let's proceed with the puzzle. Right now, we can start annotating. We see that a baker's dozen is 13, since I said so. Next, we can see down there that there's a square H. What this means about the H is that the H is square, which also means all sides are equal. We see here that the score, and if we go back to Old English, which I've taught you before, as a medieval peasant, score represents 20. So now we're ready to solve. So since we know that each edge of the H is equal, let's say x. This means that the area of the H can represent this using x squared. So now, from the first stanza, we can see that a baker's dozen of an edge of a H subtracted from the area, which lost just the H, which just represents the area that the H is on, is x squared minus 13x. Now, onto the second stanza, we see that 2 score is just 2 of 20, and adding 2, we get 42. Not a bit more just means that this whole expression equals 0, since 0 is not. Wait, not 1. So putting it all together, we have this equation, a baker's dozen of an edge of a H, subtracted from the area, which lodges the H, adding 2 and 2 score, and not a bit more. What could the two lengths be of the square HIC? How we can find x is we can factorize the equation. So we need to find two numbers that add up to 13 and multiply to 42. Let me just pull out my table here. I've listed down all the pairs of numbers that would multiply to 42 and written down their sums. So if we want to find out the two numbers which add up to 13, we get this pair. And thus, the two lengths of the square H are 6